Well, we are at the last slide set of the semester. You've made it practically, just a test and a module ahead of you, and maybe some homework if you haven't finished that yet. So we are talking about aeolian processes. This is wind-driven geomorphology, and these happen in desert landscapes primarily, but we can see aeolian processes occurring just about anywhere. The condition is as the volume of moisture in an environment increases, the volume of aeolian processes generally gives way to other forms of geomorphic process, namely fluvial and glacial. And we know that with glacial, we need a significant amount of ice formation to produce that. So we just talked about glacial formations. That's indicative of cold environments. We often consider desert environments warm environments, and indeed that's true, but we have desert landscapes at higher latitudes where it can be cool to cold. So it is not an exclusively warm desert phenomena. In fact, this is the current distribution of dry areas and sandy areas in the world. And if you take a look closely amongst the sandy areas, we've got some high latitude places near the top of Alaska, around the Arctic Ocean and the Bering Strait, a series of sandy areas scattered across the northern reaches of Russia. So really critical that we do have cold desert environments. If you look very carefully, we've got one here within British Columbia, Canada, at still a high latitude, but just below 60 degrees in terms of how high that is. And then if we look at the equivalent latitudes in Patagonia, we've got some in Argentina between 30 and 50 degrees latitude. Remember that the southern hemisphere is primarily an ocean, and that at these higher latitudes above 50, we have the Southern Ocean, which is a major volume of water rather than landscape. And we see with landscapes as well, and this dry area of the world really underpins this for us, that the further we are from a body of water, the more inherent we're going to get a desert or a dry semi-arid landscape being produced. So these areas shown in both of these maps are where we're going to find aeolian processes, which are geomorphic, most prevalent. So wind acts like a fluid. A physicist, an atmospheric scientist will tell you that it is fluid. And because it's a fluid, it's going to act just like water in terms of what it is able to accomplish in terms of removal and transportation and deposition of material. The difference is it can't carry a solute, which is going to then provide chemical erosion. The big difference with wind as opposed to water and ice as geomorphic agents is that wind is much less dense and therefore doesn't have the capability to do as much work. So it's going to erode less and transport less material. Remember, we used the words capability and capacity when we were talking about water. The capacity of wind can be quite high, but not as high as water. The capability of wind is exceptionally much lower. It is not capable of transporting large pieces. All right. Again, it's the primary erosion agent in dry environments. These are locations where there is a lack of water and there is a lack or a deficit of vegetation. That doesn't mean that there's an absence of vegetation, but that the vegetation is rather low in volume. Again, this is an aeolian process.